Have you ever stopped to think about what really holds our digital world together? I mean, it's not just code, right? It's architecture, data architecture. Today, we're going to put on our architect hats and explore the absolute core concepts of MySQL. We'll be designing and building the powerful structures that manage all our data. So, let's jump right in. Just think about the last time you were scrolling through your social media feed, or maybe you checked your bank account. Every single like, every transaction, every interaction, that's a data point. Now multiply that by billions of users, and suddenly you're looking at trillions of data points being juggled every single second. How on earth is that even possible? Well, it all comes down to the blueprint of the database. So, what even is a database when you strip it all back? Honestly, it's just a really organized collection of data. A great way to think about it is like a huge digital filing cabinet or maybe a bank vault that's storing everyone's account details. This organized structure, it's the bedrock of pretty much every single app we use today. Let's stick with that filing cabinet idea for a second, because it really helps visualize the hierarchy. The whole cabinet itself, that's your database. Now, if you open a single drawer inside, let's say it's labeled customers, that represents a table. And then when you pull out one specific folder for one person, that's a record. And that's it. That simple hierarchy, database, table, record, is how we bring order to what would otherwise be total data chaos. Okay, so every architect needs a toolkit, right? For us, that toolkit is SQL, which stands for Structured Query Language. These are the power tools we're going to use to actually build, shape, and maintain our data structures. Let's open up the toolbox and see what's inside. So inside, we find four main types of tools. You've got DDL, which is for defining the structure. Think of these as our architectural blueprints. Then there's DML, which is for manipulating the actual data that lives inside that structure. DCL, well, that controls who gets the keys to which rooms. And finally, TCL acts like our project supervisor, making sure every single change is made safely and correctly. Now, this is a really critical distinction for any architect. DDL commands are like laying the foundation or putting up walls. We're talking create or alter. These are big structural changes, and they're permanent. You can't just undo them. DML, on the other hand, that's all about what's inside the building, adding some furniture, changing a name on a mailbox. These actions, like insert or update, they aren't set in stone. And believe me, that undo capability is incredibly important. So, how do we even get that undo button? Well, that's the job of our safety net, the Transaction Control Language, or TCL. It's really clever. It bundles a set of actions together into a single transaction. What that means is if any single part of the process fails, let's say a bank transfer gets halfway through and something goes wrong, the entire thing can be rolled back. This is absolutely essential for protecting the integrity of your data. And it really just boils down to two simple, super powerful commands: commit and rollback. Think of commit like hitting the master save button. It makes all the changes in your transaction permanent. And rollback? That's your ultimate undo button, wiping out everything you did since your last save. It's a simple concept, but it has the power to prevent some absolutely catastrophic mistakes. Okay, so we have our blueprints and we've got our tools. Now, as good architects, we have to choose our building materials. In the database world, these materials are our data types. And let me tell you, choosing the right material for the job is absolutely critical for performance, for efficiency, and for building a structure that's actually going to last. Let's start with text, where we have two main choices: CHAR and VARCHAR. You can think of CHAR as a fixed-sized brick. It's super fast if you know your data is always the same length, like a 2-letter country code. But if your data is shorter, you just end up wasting space. VARCHAR, on the other hand, is like an elastic material. It's perfect for things that change in length, like people's names or email addresses, because it only uses the space it actually needs. This is a classic architectural trade-off. Do you want raw speed, or do you want to be efficient with your storage? Now, when it comes to the character set for your text, basically the language it understands, the modern standard is, without a doubt, UTF-8MB4. Why? Because it supports pretty much every language on the planet, from Chinese characters to Cyrillic script. Oh, and it's also what lets you store emojis directly in your database. Using anything older is just asking for trouble and risks cutting off a global audience. For handling time, you've got two main tools. Timestamp is your go-to for tracking when something happened. Like, when was this blog post last updated? It's compact and it's aware of time zones. But for fixed, unchanging moments in time, like a birthday, you'll want to use datetime. It stores an absolute value that doesn't care where your server is located, and it has a ridiculously enormous date range. And for numbers, it's all about picking the right size for the job. You wouldn't use a giant shipping container to hold a single screw, right? Same idea. A tiny int is perfect for simple yes-no flags. A big int can handle enormous numbers, like transaction IDs. And here's a great pro tip for efficiency. If you know you'll only ever store positive numbers, use the unsigned option. It literally doubles your positive range without using a single extra byte of space. All right, let's head down to the engine room. We've got our blueprints, we've picked our materials, but what's the machine that's actually doing all the heavy lifting of storing and retrieving the data? That's the storage engine. Think of it as the fundamental operating system for your tables. It defines how they perform and how they behave under pressure. So this choice often comes down to two main players. First, you have InnoDB. It's the default for a reason. It's a bank vault. It's built for safety, for data integrity, and it's what makes those TCL transactions we talked about even possible. On the other side, you have MyISAM, which is a race car. It is blazingly fast for operations where you're mostly just reading data, like for a blog or a product catalog, and it's a champion at full-text search. The choice used to be a really stark trade-off, but modern InnoDB has gotten so fast that for most apps, its safety features make it the clear winner. But, for those niche, high-read situations, MySam can still be a really powerful tool. So, with these engines, just how big can we build? The scale is, well, it's staggering. A single table, whether it's using InnoDB or MyISAM, can grow up to 256 terabytes. To put that into perspective, that's thousands and thousands of hours of high-definition video. This isn't just a filing cabinet anymore. It's a system that's designed for a nearly limitless data horizon. So let's bring it all back to our core architectural principles. A great data architect always prioritizes efficiency by choosing the right materials or data types. They ensure integrity by building in safety nets like transactions. And they design for scalability, knowing their foundation can support massive growth. It's all about building smart, right from the ground up, while also keeping practical limits, like that maximum row size, in the back of your mind. In the end, every single database is an act of architecture. Your data already has a blueprint, whether you designed it intentionally or not. So the real question this leaves us with is this: are you consciously choosing the right materials and using the right tools? Are you building something that's just functional for today? Or are you architecting a structure that's robust, efficient, and truly built to last?